Hello everyone and welcome to another rapid maths session. In this video we will look at a special case of multiplication. Multiplication by 11. So let's continue by looking at this problem. What is 34 times 11? Now I'm going to use two terms regularly in this video, so let me quickly introduce them. Multiplicand and multiplier. I'll refer to the first number or 34 in this case as the multiplicand, and the second number or 11 in this case will be referred to as the multiplier. Great, with that established, let's get back to our problem. It's immediately evident that there are a few things that make this problem easy to solve. Firstly, the digits of the multiplier are the same. Another equally important point is that both digits are 1, which means that we really do not need to do any multiplication. Taking these facts into account, we can quickly find our answer using the conventional method. Here it is. The answer was quick, but we still had to go through 2 iterations and then add up the numbers before arriving at our final answer. Could we have done better? Alright, let's look at an alternative method used in multiplication by 11 problems. Let's see how it works by applying it to the problem we just saw. So here's the problem once again. 34 times 11. And now let's focus on the multiplicand. I'm going to write down both digits with a gap in between them. Now let's add up the digits. 3 plus 4 is equal to 7. Let's put the 7 into the gap. We are left with 374, which is the correct answer. That was fast, actually much faster, right? Let's attempt another problem. What is 53 times 11? As before, we write down both digits of the multiplicand with a gap between them. We then add up the digits. 5 plus 3 is equal to 8. And this gives us 583, our final answer. Now in both the above examples, the multiplicands had 2 digits. In this next problem, we will deal with the larger multiplicand. So what is 523 times 11? As before, let's put down the first and last digit. And now, starting from the right, let's pair the numbers and add their results. So here's our first pair, 23. 2 plus 3 is equal to 5, and we add it to our result. Here's our next pair, 52. 5 plus 2 is 7, and let's add it to our result. We are left with 5753, our final answer. So let's see if it's correct. Yes, it is the correct answer. Now in this next problem, we will introduce a new level of complexity, carried over digits. What is 67 times 11? As before, we write down both digits. We then add our digits. 6 plus 7 is equal to 13. Now what do? Do we write 13 in the gap as before? Let's do so and see what happens. Our answer is 6137, but is it correct? Let's find out. Tough luck, the answer is incorrect. What we should have done is write down the 3 and carry over the 1, like this. And because of this carried over 1, our 6 here becomes a 7. This gives us 737, which is the final and correct answer. Alright, let's raise the bar on this next problem. What is 5923 times 11? We first write down the first and last digit. And let's now pair digits and add, starting from the right. 2 plus 3 is equal to 5, Let's write that down. 9 plus 2 is equal to 11. We bring down a 1 and carry over the other 1 like this. 5 plus 9 is equal to 14. Adding the carried over 1, we get 15. So we bring down the 5 and carry over the 1. And finally, we change this 5 here to 6 because of the carried over 1. This leaves us with 65,153. Let's check our result. Correct once again. I will now conclude this session with another monster problem. What is 25,061,903 times 11? If at this point you are thinking, what's the big deal, then hold on to that thought. As a teacher, it makes me very happy since it means you have grasped the concept and are unafraid to apply it to large numbers. But take a look at the solution all the same, please. Now this is unlikely, but just in case you wondered where 25,061,903 came from, well guys, this is the birth date of that great novelist and journalist George Orwell. And in conclusion, here's one of his popular quotes. Thanks a lot.